Welcome back. We're on page 304 talking about the performance of a system and how sometimes that's difficult to kind of articulate. So we talked about functionality and we talked about system output. The next one is kind of performance. So how well does it perform? And you could ask some questions here. For example, let's say I'm getting ready to do some performance testing. Do I test with 100 users or 50 or 1,000? In other words, how do I, what's my gauge of performance? And it could be something simple like, transactions per second. It has to be able to have so many transactions per second. Or it could be, response time within 20 milliseconds. Or it could be how many simultaneous users, those kinds of things. So these are, does it meet all the functions? That's kind of a checklist, isn't it? Yes, no, there's not really much subjectivity. System output, is it timely? Is it accurate? Is it easy to understand? Is it in the right format? Those are kind of checklists. Performance, is it under 20 milliseconds? You can just kind of go through and say yes, yes, yes. Okay. Reliability. So under normal circumstances, which is not really defined, under normal circumstances, does it work or does it crash? Remember we talked about 5 nines availability. It's a topic that comes up a lot in the computer world. But, pardon me, what's the acceptable downtime? Can I be down for like a day? 1 day, a year? Is that okay? 24 hours is fine? Or is my system so critical that I can't have more than like 5 minutes worth of downtime in an entire year? And so that kind of stuff you kind of need to know in your measurement system. You go through. So how reliable is the system? Okay, and the next one is the maintainability. And they kind of go off on a wild tangent here, so I'm kind of ignoring that paragraph in the book and putting my own spin to it. So maintainability is, how difficult is it going to be to, double the size of this thing, add more users or add more features or swap out the database or do patches? How difficult is it to do I have to have downtime to be able to add a new user to the system? I have to shut the system down or reboot it? I mean, how easy is it to operate and maintain and keep this thing going? When it comes time to upgrades, can I do it live? Or do I have to reboot the system every time I do an upgrade? So, planning for quality management. All right, we didn't really talk about planning much, but you can probably imagine the planning part is going to be going through and saying, okay, here's what I want. Here's the functionality I want. Here's the output I want. Here's the performance I want. And just going through and saying, our plan is to provide these standards, these criteria, whatever these things are called. Continuing on page 306, they talk about performing quality assurance. Okay, so after planning becomes ensuring. So I'm trying to ensure that things are following the plan. So this does kind of sort of sound like supervision, doesn't it? I have a plan that quality control is supposed to do, and so I'm kind of in the middle there trying to make sure that things are working. So quality assurance, yet another goofy definition. All the activities ensure the satisfaction of the quality standards. So I've put together in my planning section, I put together a whole series of quality standards that I want. And so this is making sure that I'm actually meeting all those stated goals. That 20 millisecond response time thing that the quality control people are actually going to be measuring. And so I just check to see, did you measure that? Okay. In addition to that kind of canned version of the definition, it's also using feedback to make improvements. So you've probably heard the term, continuous quality improvement, that kind of thing, where the idea isn't, again, the idea for quality control and quality assurance isn't to catch and punish the guilty. That's not what it's about. It's about making things better. Yes, something happened and the quality got off. Now let's bring it back in line. Okay. So a quality assurance plan would basically say, make sure these things, don't happen, and here's how you do it. And let's don't punish people when it does occur. Okay? Because if you start punishing people, they're going to suppress, negative feedback and never tell you that they have a problem. That's not what you want. Okay. So, one more time. It's not enough to say, yes, the quality has slipped. Obviously, the part 2 to that, for the other shoe to fall, is I need to do something about it. So quality assurance is going to help you in the doing something part. Okay, there's a couple of phrases they throw in and different types of technologies, and one of them is called lean. You probably have heard this, maybe, I don't know. So lean is all about this concept of eliminating waste. And lean basically means every time I reject, to tell you the truth, if we were talking a production line and not IT, this would be a heck of a lot easier conversation. I'm producing, boots. And so I'm producing boots, and they're supposed to be size 9 boots. And so every once in a while I'll go grab one, and I measure it, and I go, man, this sucker is way too small. This is not going to fit a size 9 foot. So I had no choice but to throw those away. So I'm wasting material because I have a reject. And so lean is all about make sure you don't have any waste. And the way you eliminate waste or reduce waste is to not have things out of tolerance. So make your control processes responsible for not wasting time and energy and money and material. Okay, cool. Now back. So the idea, if you were to take the whole lean methodology and break it into a single phrase, it would basically be do it right the first time. That's essentially what that philosophy is all about. The next term they talk about is benchmarking, and we've talked about benchmarking before with regard to Microsoft Project. And benchmarking is all about here's what I think the things are supposed to do, and I'm going to measure my own performance against myself. And let me just give you an example from another branch of IT. That is, I put in a brand new server, and I measure response time to this new database. And so it responds within 200 milliseconds on average for a day. And so I chart that over time. In January it did 200, and in February it did 210, and then March, and I noticed that the trend's kind of increasing because we're adding more users and more customers, and so I'm benchmarking against myself. Here's what it had at the beginning of when it was first installed, and here's how it's performing now. I may have to do something. Well, that's what it is here in quality. What is my benchmark? So it's comparing your performance against some sort of a goal. And benchmarking most of the time is not just an arbitrary goal that somebody just picked. It's typically something that you sat down and said, this is definitely achievable. These are not stretch goals, right? These are traditional goals. This is if you do this well, you're good. We're not talking about being superlative and having stretch goals. This is like the minimum quality thing. Okay, benchmarking. Now, it's very possible you would have your own internal, but on the other hand, perhaps not. Maybe you're going to go to some industry standard thing. Across the industry, the average access time for a database is 200 milliseconds. Okay, then I'll just grab that one because that sounds like a good benchmark to be using against. So is our system better than that or worse than that? Okay. The quality audit. So audit, and again, they go into these crazy definitions, but here we go. A structured review of a particular quality activity. Okay. Well, audit basically is what it is. I'm going to pick a particular item, one particular thing. Let's go back to the performance one, and let's say that you've picked, when you're doing your planning section, you said I want the performance for this particular database to have this type of request fulfilled within 200 milliseconds. That's my performance goal. Well, then here's where we're actually going to go in and say, so show me what the results of your quality control measures are. Pick one, not all of them, but pick one and say, hey, show me last week's numbers on the number of response times in milliseconds. So, okay. So you sit down and you go through it. So that's what the quality audit is all about. I will tell you that there could be some problems. Let me explain some of the human nature piece of this. And this gets a little weird, but here, how about this? Let's say you're a super duper high paid IT person, okay? You're a super duper database administrator and you're pulling 6 figures, okay? And then you have an auditor or a quality control person who's making half of your salary, okay? And they're basically telling you, hey, your stuff ain't good enough. That's going to be a problem. You really can't have junior people saying to the senior people, hey, your stuff's getting out of whack here, you need to fix it. Okay? I'm just telling you, from a human nature point of view, the quality, this is the reason why it doesn't all happen in the control part. It has to happen in the quality assurance part as well. This is where the supervision comes in, okay? Okay. In fact, in most organizations, quality control and quality assurance are not the same people. They are separate teams. Okay, all right, let me continue. So a quality audit could be random. It could be scheduled. It could be, okay, every Tuesday we're going to look at, one of these features. Or it could be just completely random. We just pick a time and we show up and say, show me your quality control stuff. Okay. So one more time, the ultimate goal of this quality assurance thing is to make sure that the project manager is ultimately responsible for the quality. That's the bottom line. This is the supervision part. This is the reason why the project manager gets paid big bucks right here. Because they're the one who's ultimately responsible for the quality assurance program. Okay, cool. All right, so moving along, now we're into controlling quality on page 307. All right, so again, the goal is not to catch errors. That's not the goal. The goal is to improve quality. Okay. So if you're thinking about, a good analogy is, did I make a passing grade on the quiz? That's not what we're after here. What we're after here is, did you learn something? Same thing here. The goal is to improve quality, not a score. Okay, it's not a number. Okay, cool. So one of the main outputs of some sort of a quality control activity. So there's a bunch of them. And so three major outputs they talk about. One is acceptance testing. Now, acceptance testing basically is a go, no-go. And there typically isn't shades of gray. It either passed or did not pass. That's it. Okay. So it's some sort of a threshold that says, of this particular sample, and we'll get into sample sizes a little bit later. But, I pull some samples, and if more than 4 of them have defects, I reject the whole lot. So that's kind of how it works, so the acceptance testing. So you take a batch, a sample, and if the results are bad, I typically, flunk the entire lot, the entire production. The next one talks about rework, which is exactly what it sounds like. Oops, I need to go and redo those over again. Either I throw them away and they go in the trash bin, or they get reworked. Either way, that's expensive. Now, if you recall from a previous chapter, we're talking about the little time scale about if you catch the error at the beginning, it costs you practically nothing. And then a little later on, and then finally you get to the end after you've published the software and it's out, and then you have to make a change to it. That's very expensive. Well, that's the same thing here. That the idea of all rework is relatively expensive, because it basically says, it would have cost me 15 cents to go over there and add a washer onto this thing to tighten it down. It would have cost me 15 cents, but instead I had to throw away a whole bunch of boots because the boots are too small. Okay, so, right? The cost of doing it right the first time is a heck of a lot less than the cost of all the waste involved. Okay, we're coming up on the 15-minute mark, so we'll go ahead and just pause this and continue again in just a few.